Okay. So question one, I hope you're able to see. Question one is just asking you to determine the convergence and divergence of a given sequence. Okay. So what it is here is that when you are being asked to determine the convergence and divergence of a sequence, this is pretty straightforward. It has no much work to it. It's similar to when you are being asked to determine the convergence as well as the divergence of a series. So obviously, what you are trying to refer to is you are given a series, let's say a sub n. You are trying to evaluate it. It's more like you're going to be saying the limit as, let's say, as n approaches some big value, which we just simply in general indicate as infinity. You have your a sub n there. So you're trying to determine what is happening for that sequence there. Okay, so what it is that depending on the nature of the question that you have, there are several methods that you are going to use, and I'm going to generalize this. Okay, and I'm just going to what I mean by generalizing is I'm also going to give points that you can use when you're determining the convergence of a series Of course, now we're talking about a sequence. So one some certain things that you need to remember is you need to remember more especially the ratio test, which I believe works the most. You're going to talk about the root test. Okay, the root test, you need to remember this. You're going to talk about the integral test. Okay, integral test. You can talk about the comparison test. Okay, comparison test. When you talk about comparison test, you have the direct comparison, okay, and the limit comparison. Then you can also know how to identify functions such as you can know maybe this is a harmonic series, or say this is a p series. Okay, you need to be able to identify those, and they're going to make your work much easier. Okay, so that is the idea there. So when you look at some questions, one thing that I'm going to do is try to simplify work for you. Is there are some questions, for example, what I would advise you, some questions, anytime you see a factorial, for example, if you look at this question here, D, when I see a factorial, the easiest method that I can use, okay, the easiest method that I can use for me, that would help me to get rid of that factorial, to really know what is happening in terms of as I'm evaluating that sequence or series. It's I need to find the best way to cancel out that factorial that I have. So it's more like someone gives me a sub n is equals to, say, minus 4 to the n divide by n factorial, like that. Okay, so when I see a factorial, or when you see factorials, I advise you try to apply the ratio test as fast as you can. That is going to save your time. Okay, you might think of other methods, but the ratio test works best. Okay, so what it is about the ratio test is that what you do about the result that you get under the ratio test and the root test, they are similar. It's just that it's different the way you take it. Okay, so what happens is that for the ratio test, okay, for the ratio test, you're going to be evaluating, say, the limit as, say, n approaches infinity. Here you're going to say a sub n plus 1 divide by a sub n. Those are absolute value symbols. Okay, so here you're going to get L. Okay, so the value of L that you get, there's when your L is greater than 1, there's when your L is less than 1, and there's when your L is equals to 1. Okay, so what you need to remember is this: on all of them, when L is greater than 1, after performing this evaluation here, when the value of L that you get is greater than 1, just not to say the sequence that you have or the series does what? Diverges. Okay, when it's less than 1, it converges. Okay, when it's equals to 1, when the value of A is equals to 1, meaning this is, you can't make a conclusion. I'll just say this is inconclusive. Okay, you can't make a conclusion from here. That's what you need to remember. So your a sub n, for example, if I use this as a, if I use this same one here to illustrate this, if you say your a sub n plus 1, let it be equals to, so what you have here, this would be more like anywhere where you have n, you need to add the 1. Okay, that would be minus 4 to the power n plus 1. But for convenience's sake, instead of me saying n to the minus 4 to the power n plus 1, I'm going to multiply by what? I'm going to multiply by minus 4. What I've just done here is it's more like someone gives me x to the power n plus 1 and say this is equals to x to the power n multiplied by x. This is true. Okay, because the bases were the same, so you just add the powers. So that is that. So the reason why I'm writing it in this way is because there is obviously something that you have to cancel out when you're dealing with the ratio test. Okay, so this is divide by. Here I have n factorial. This is going to be n factorial n plus 1 multiplied by n factorial. Why am I doing this? I was supposed to, in a normal sense, I was supposed to say n plus 1 factorial like this. But what I've seen is that since it's obvious there's something that I'll have to cancel out, I can't cancel out this one with this n factorial that I have. So the best way to write it is that you need to remember in terms of factorials, n plus 1 multiplied by n factorial is the same as n plus 1 factorial. You can try it out. If you try this value here, okay, is 1 unit bigger than this one. Okay, so if let's say your n is 5, if you plug in, if you say your n is equals to 5, if you say this is 5 plus 1, okay, then you say n, which is 5 factorial, is equals to, here you say 5 plus 1 factorial. This is what you're going to get here. This is going to be 6 multiplied by 5 factorial is equals to 5 plus 1 is a 6 factorial. So this and that are the same. So you should always try to do that in terms of factorials. Don't just go and write it this way. You're going to fail to cancel it out. So what I've written here and what I have here is one and the same thing. But the way I've written it is the best way, because you have to cancel out something from the numerator and something from the denominator. So to evaluate this, it would be like the limit as n approaches infinity. Your a sub n need to be on the numerator, which you can write as minus 4 to the power n multiplied by minus 4 divided by n plus 1 multiplied by n factorial. I was supposed to say divide by a sub n, but I'm going to multiply by the reciprocal of a sub n. Okay, I'll multiply by n factorial divided by minus 4 to the power n, like that. Okay, so you can clearly observe to say I can cancel out this and that, I can cancel out this and that. Okay, so what do I remain with? What I remain with is something, of course, very convenient to work with. It's like the limit as n approaches infinity. Okay, on the top I'm going to have, I can just write this as a 4 because it's an absolute value anyway. So that's going to be a 4 divided by what do you have? You have your n plus 1. Okay, so now what is remaining is for me to evaluate this. So here is how you can make a mistake sometimes. If you come here and just substitute infinity there, you're going to get 4 over infinity plus 1, which is going to give you a 0. Okay, which is true, but the reason why I would avoid sometimes doing this is okay, this is okay. I think for this question this is okay, you can apply it. In fact, where we have reached on this question, there are 3 things that you can do. First thing, you can think of the direct comparison test. By direct comparison is that I'm going to think of what is significant. Okay, when n goes to infinity, it doesn't really matter. This one here is so insignificant. Okay, like it doesn't add any value to infinity. Okay, it has no effect whatsoever. So the most significant part of what you have here is what is your 4 over what? 4 over n. If you evaluate this as n goes to let me see, as n goes to infinity, this you're going to find that when you substitute here, this will be 4 over infinity, which is actually a 0. So just get a 0. Another way you can think of it is that you can actually manipulate it. What I can do is that I'm going to multiply everything by 1 over n. Okay, 1 over n, meaning I'll say 1 over n. And you see why I'm doing this. That will be the limit as n approaches infinity. So 1 over n multiplied by 4, that will be 4 over n divided by 1 over n by n is a 1 plus 1 over n by 1 is 1 over n. So if you plug in infinity here and infinity here, we get a 0. So this would be like 0 divided by 1 plus 0, which is actually 0 divided by 1, which is a 0. So because what we have gotten is a 0, so this simply means This simply means our value of L is 0, which is less than 1. So if it's less than 1, it simply means it converges. Okay, that's about the ratio test. So these questions is just about the best method that you can apply to evaluate the question that you have. Yeah, once again, I'm just hoping you guys are able to get me. I'm not using my headsets today. Yeah. So going to the next question, which is question 2, which is saying find the nth partial sum of each of the following series. And by the way, if you have a question, feel free to interrupt me. I'll be able to attend to you. Question 2 says find the nth partial sum of each of the following series, hence determine whether the series converges or diverges. So one thing I would love to explain about the nth partial sum, if you are given some values, okay, if you're given a set of some values such as a1, a2, a3, a4, a5. So if someone is talking about the nth term, okay, the nth term, what the nth term does is that sometimes you find people confusing the nth term and what does this question say? The nth partial sum. Okay, yeah, Milda, you are raising your hand. Milda, you are raising your hand. Talk to me. Unfortunately, I can't get anything. That's if you're trying to say something, I can't get nothing. I'm not sure if it's your internet or something, but I can't get anything. Okay, so I'll carry on. Okay, so the nth term and the nth partial sum, you say nth uh, partial sum. So the difference is that the nth term is more like it's a formula that gives you, let's say if I ask you to say, give me the 20th term, okay, the 20th term, use the nth term formula. The sum of 20 terms, use the nth partial sum. That's what you do, okay? So remember, nth term gives you an exact term. If I ask you for the 100th term, use the nth term. If I ask you for the sum of 100 terms, meaning you use the nth partial sum. So how you come up with your how you come up with your nth partial sum is that if you look at the question that we have, uh, the question that we have from this tutorial sheet, this that we are given here is not the nth partial sum, that's the nth term, okay? This is the formula that we are using to come up with these values there, okay? So let me pick, which one can I pick as an example? Okay, let me use the first one. Let me use A as an example, which is 4 plus 4 over 3 plus 4 over 9 plus 4 over 27. Okay, so we are given the first term, which is 4, comma, it's actually plus, it's a series, plus 4 over 3 plus 4 over 9 plus 4 over 27. Okay, so this is plus, then you have been given the nth formula, which is your a sub n, which is 4 over 3 to the power n minus 1. So the nth partial sum, the way you get it is that you're going to say it's like the first term is just 4. Sum of this sum of the first two terms will be, so it's like this is the sum of the first term. Sum of the first term is just the first term itself. Sum of the sum of the first two terms, it's 4 plus 4 over 3. Then sum of the first three terms, it will be 4 plus 4 over 3 plus 4 over 9. Then sum of the first four terms, which is what I have actually, that is 4 plus 4 over 3 plus 4 over 9 plus 4 over 29. Okay, so this still gives me a 4. Okay, this is equals to, so if you make this a single fraction, that's going to be 3 by 4, that's a 12. 12 plus what is this, 12 plus 12 plus 4, that would be 16. So it would be 16 over, I think 16 over 3. 16 over 3. Then this one, we say 16 over 3 plus 4 over 9. 16 over 3 plus, I don't want to use decimal places, it's okay like this. So 16 over 3 plus plus that, what can we get? So 16 times 3 is actually 40, is it 48? Plus 4 divide by 9, that is going to be 52. Divide by 9. What do you think you're going to get on the last one? What expression are you going to have? Of course, I know to say this part here gives me 52 over 9. What do we get when you say 52 over 9 plus 4 over 27? What do we get there in terms of fractions? Anyone? What do we get? So I'm getting 159 divided by 27. No, wait a minute. It's actually 160. I'm getting 160 divided by 27. Okay, we get 160 divided by 27. Do you agree with me to say those are the terms? I'm hoping so. So these terms that we have here, it's more like here we have 4 divided by 1, just that we didn't indicate it. So first of all, you can think of what for you to write the nth partial sum. Okay, when you think of the nth partial sum, is it's a formula that gives that. Here's like we're just looking for a formula here. Okay, so I'm going to address first of all the denominator. When you address the denominator is when it's moving in this way. You have 1, 3, 9, 27. So I think what this is it's something to the power 3. Okay, it's something to the power 3. So this, I think it would be, since this is a 1, it's obvious that was going to be 3 to the power 0. So if that is 3 to the power 0, meaning it's like maybe I would have 3 to the power n minus 1. That would work out because, for example, if you look at this 27 here, if we come and say 3 to the power, here your s, is s sub 4, so meaning your n is a 4. So we're going to say 4 minus 1, that would be 3 to the power 3, that is actually 27. So the denominator, we have addressed the denominator, which is we have addressed the denominator, which is going to be 3 to the power n minus 1. Okay, what do you think the numerator is going to be? Anyone? What do you think the numerator is going to be? This might work out. Let me try it out. So if you say 6 multiplied by 3 to the power n minus 1 minus 2, let me see if this can work out. If you plug in 1 here, this will be 0, so that's going to be 4. If you plug in 2, that would be a 1. So 3 times 3 times 6 is 18. 18 minus 2 is a 16. Okay, that makes sense. So if you plug in 3, that would be n minus 3 minus 1, that would be a 2. Then this would be 9. Okay, that would be 9. So if you say 9 times 6, 9 times 6, you get 54, minus 2, you get 52. So the numerator is 6 multiplied by 3 to the power n minus 1 minus 2. So this is the nth partial sum. Is that part okay? Anyone left behind? Anyone left behind? Okay, I hope not. So that's that about the nth partial sum. Just add all the terms, like starting with the first one, then first one plus second, then first, second, third, then first, second, third, fourth, just like that. Then you come up with a formula. Then this formula here, you determine if it diverges or it converges. You can apply any of the tests that we have talked about. Okay, so question 3, this as well is open. These questions is it's just about the best method you can think of applying. That is what might work out for you. Okay, so one thing I advise is for some of them here, you can think of applying the ratio test, applying the root test. Mute, you're trying to say something? Hello? Okay, so question 3 is just about determining or observing the best method that you can use to simplify what you are given, to determine the convergence, as well as the whether it's converging or diverging. And usually sometimes if it's converging, what is it converging to? you have to know that. Okay, so having done an example on question 1, I won't waste much time on question 3. You can try them out. If you get stuck, try to apply the ratio test and the root test as well as the other tests just to simplify your work. If you don't manage, then I'm here. Okay, then when it comes to the integral test, okay, when it comes to the integral test, this is also pretty basic. That is under question 4. So the integral test is just about, if you are given a series, say starting from n is equals to k to, let me say, going as far as infinity of a sub n. Okay, so what happens is that if I'm to use the integral test, I need to remember that my starting point here, it will be like this. Okay, the lower limit is still going to be k, the upper limit is still going to be what? It's going to be a sub, it's going to be infinity. Then this a sub n will have to change to what? To f of x dx. Okay, so there are just some few conditions that you have to keep in mind as you use the integral test. Anyone who remembers those? Because usually the question they ask you to say verify the integral test and then continue to work the question out. Anyone who remembers the conditions that needs to be taken into consideration when looking at the integral test? Anyone? I need to try to get some feedback. Do we remember what the conditions are that we have to keep in mind under the integral test? Okay, anyway, let me carry on. So the idea is that if you're given your a sub n, which you're obviously going to write as your f of x, provided it's positive, okay, provided it's positive and it's continuous, not just being positive and continuous, and it's decreasing, okay, decreasing for x greater than or equal to 1, then you can apply the integral test. So when the question is asking you to verify, if you look at this tutorial sheet that we have, it says verify that the integral test can be applied on the following. So meaning, if the series that you have, which you can write as your f of x, if it's positive, continuous, and decreasing for x greater than or equal to 1, meaning you can go ahead and use the integral test, of which the examples that were given, you can try to sketch them. They are obviously positive and they are continuous and they are decreasing, meaning when talking about a function decreasing, what it means is that you have something like this. Let's say that's our vertical axis, and say this is our horizontal axis. So if it's decreasing, let's say it's something of this kind, okay, and it's continuous, yes, it's continuous. It's positive, yes, it's positive, meaning it's on the upper part of the what? Of the y-axis, meaning it's on the positive part of the y-axis, okay. So it means for all the inputs of the x that we have, what we get is the positive output. That's what we mean by it being positive, continuous, and decreasing for x greater than or equal to 1. Okay, so if you look at the examples that we are given, I'll use example 4a, that is 1 divided by n by ln of n to the power 2. Okay, so the way this is going to work out is that of course you just have to remember some methods of integration here. this is going to be something like you are given your a sub n to be equals to 1 over, is it 1 over n, sorry, it's 1 over n multiplied by ln of n then squared there, something like that. Is it, let me just confirm on my phone here, where's my tutorial sheet? Yeah, something like that. So it simply means here your f of x is just going to be equals to 1 divided by x ln of x, then here that would be squared like that. Okay, that's what we have. So here it simply means you are, if you look at where this is starting from, it's something like this, starting from 2 to infinity. So it simply means your lower limit is a 2, your upper limit is infinity, then divide by 1, then here you have ln of sorry, you have x, here, then you have ln of x to the power 2 there, then here you're going to have dx. So what best method do you think can work out here to integrate this? Do you think u substitution can work? If we let u, for example, be equals to ln of x, meaning du be equals to 1 over x dx, so dx will obviously be equals to x x x du. Okay, so that would be 2 to infinity, then 1 over, you have x, then you have u squared here. Instead of dx, I'm going to put x du, that and that can go. So what do you have? You have 2 to infinity, meaning this is going to be u to the power negative 2. Du to integrate, this is just going to be minus 1 over u, evaluating from 2 to what? To infinity. Okay, so you can evaluate it from here, like, meaning you have to change this back to, instead of u use ln of x, or what you can do is that you can find the units of the limits of u in terms of x. So what this is that you can say u is equals to, the upper limit is infinity, so if you say ln of infinity, it's still going to be infinity. But if you say ln of 2, this will just be ln of 2. So meaning here, if I'm to evaluate in terms of u, instead of having 2 here, this would be ln of 2. Okay, so if you say minus this would be minus 1 over infinity minus 1 over ln of 2. Okay, that's ln of 2. So this will give you a 0, then this minus and this minus is going to give you positive. So our answer is simply 1 over ln of 2. That's the answer there. Any question when it comes to the integral test? Do we have any question? People are leaving the meeting. Are you guys able to hear me clearly? Or what's happening? Yes, Milda. Okay. Okay. Where's question 3? You said Milda in the group is asking, say on question 3, is it okay to just substitute where there's n, you put what's given on? I don't kind of understand the question. So the idea is it depends on what you have. For example, if you're using the if you're using the, say you're using the ratio test, I don't know what test that you'd be using. If you're using the ratio test where there's n, you need to substitute with n plus 1, because you're going to have your n plus a sub n plus 1 divided by a sub n. If you this is the ratio test. If you're using the root test, the root test is about nth root of absolute value of a sub n, and this is suitable for those series that are raised to the power n. For example, if you have 2 to the power n multiplied by 3 to the power n divided by, say, maybe e to the power n, you can use the root test there. This will help you cancel out this n, meaning this can be written as 2 multiplied by 3 to the power, sorry, multiplied by 3 divided by e, that would be to the power n. If you plug it here, that n is going to cancel out, meaning just remain with 6 divided by e, which is your answer. So I'm not sure if what you were asking is related to what I've answered, but if it's a root test, if it's a ratio test, you add, where there's n, add n plus 1. How about just going direct where it applies? I don't understand what you mean going direct. Okay, I'll attend to Milda's question when she's trying to record in the group. Yeah. So in the meantime, any queries when it comes to the integral test? I hope there isn't. Okay. So question 5, use the direct comparison test to determine the convergence or divergence of the following series. So the idea of the direct comparison test is pretty simple. What you have to remember is when you're given an expression, let's say one of the examples that is given there, we are talking about question 5, remember, we are using the direct comparison test. So this is a series from n is equals to 1 to infinity. We have 1 divided by 2n minus 3. So the idea is the direct comparison test works in this way. Just focus on what is significant in the expression that you have. So one thing that I'm able to observe here is that this minus 3, as this one goes to infinity, this minus 3, it will be redundant. Okay, so meaning I'm just going to focus my attention on the part that is the most significant, okay, to determine whether it converges or it diverges, and if it converges, what value does it converge to. Okay, so what it is that I'm going to have 1 divided by 2n. This is the most significant part. Okay, so now here it's like it's just a matter of evaluating the limit as n approaches infinity of 1 divided by 2n, like that. Okay, so here if you look at what you have, this is 2n, not 2 to the power n. Okay, so how you evaluate this is literally up to you. I can choose to simplify this myself and say, okay, the limit as n approaches infinity, which I can write as 1 divided by n divided by 2. Okay, this here gives me a 0. So you get something like 0 divided by 2, which is equals to 0, converges to 0. Okay, so the idea about direct comparison test, pick the most significant part. Even if you look at the first one, that is question 5a, you are given the series starting from n is equals to 2, I think, to infinity, and that is ln of n divided by n to the power 3. This n to the power 3 is more significant compared to what you have on the numerator, so I can choose to use 1 divided by n to the power 3 as the reference point of determining whether it converges or it diverges. So meaning that would be like the limit as n approaches infinity of 1 divided by n to the power 3, because this is the most significant part. Okay, so what happens here is if you look at this, this is just more like a p series where p is greater than 1, and if p is greater than 1, meaning it converges, because in this case our p is equals to 3, which is obviously greater than 1, meaning it converges. Direct comparison test, focus on the most significant part of the series that you are given. You should always remember that. Okay, so the reason why I'm overemphasizing the fact that you need to pick the most significant part is I'm still going to use this when I talk about the limit comparison test, which is question 6. Question 6 talks about the using the limit comparison test. Okay, so when you're using the limit comparison test, when you're using the limit comparison test, the idea is you're going to be writing, you're going to have your series in the form, let's say, limit as n approaches infinity, okay, of this could be like your a sub n divided by your b sub n. Okay, so this will be this, the solution here. Okay, the solution here is going to be given as L. Okay, so now this L, first of all, you have to look at what is happening with b sub n. So b sub n is the most significant part of a sub n. Okay, is the most significant part of a sub n. So what happens is that if b sub n diverges, this whole expression is going to diverge. That is if and only if your L is positive. Okay, if your A is positive and finite. Okay, remember this. And of course, you're talking about being greater than 0. So it's not just about even infinity. Even infinity is greater than 0. We all know that. But we are looking at a finite number such as a 2, a 1, a 3, or something, but 0. And so it should also be what? It should be positive as well. So your b sub n, keep in mind, is the most significant part of your a sub n. So what you do is that pick your b sub n, determine if it diverges or converges. So meaning if it converges, this whole expression is going to converge if and only if your L is positive, greater than 0, and finite. Okay, so let's go ahead and look at an example. So if you got your tutorial sheet, I'm using my phone now to pick a question. You can, I believe you have the tutorial sheet there with you. If you look at question 6b, which is 5 over that is 4 to the power n plus 3 there. So you observe to say the most significant part of this is actually 5 divided by 4 to the power n. Okay, so that's more like your b sub n will be equals to 5 divided by 4 to the power n. What happens here is that I'm going to say the limit as n approaches infinity of 5 divided by 4 to the power n. What does this do? Like what am I going to do? So this is going to be what is it going to be? So you can use any tests here to determine what this is going to happen. You can use the root test or the ratio test, but maybe the ratio test would be much favorable. Your a sub n plus 1 will be equals to 5 over 4 to the n multiplied by 4. Okay, so which if you say the limit as n approaches infinity of, sorry, let me use b sub n in this case since you're using b sub n. So b sub n plus 1, I find that is 5 over 4 to the power n multiplied by 4 multiplied by the reciprocal of b sub n itself, which is 4 to the n divided by 5. So this is like that cancels and that cancels. Okay, this cancels and that cancels. We end up with 1 over 4. That's what we have. Okay, so this we observe to say this converges. Okay, we have gotten 1 over 4 that converges. So now, meaning even the whole expression that we are trying to put across here, it also converges. if and only if the value of L that we find is finite and it's greater than 0. Okay, so as n approaches infinity, this will be equals to our a sub n is actually this same one that we have, okay, which is 5 divided by 4 to the n plus 3. I'll say multiplied by reciprocal of b sub n, which is 4 to the n divided by 5. So this and that you can cancel out, so meaning that will be the limit as n approaches infinity of, that would be 4 to the n divided by 4 to the n plus 3 there, of which one thing that you're able to observe here is that this again is less significant. So the most significant part is this one. So that would just be more like 4 to the n divided by 4 to the n, which gives you a 1. So this value of L, this is the value of L, you observe to say is positive and is finite. So meaning this expression here converges. First, what I did was I determined my b sub n, which is the most significant part of a sub n. I found that it converges. So for me to confirm that this whole expression also converges, I had to say a sub n divided by b sub n. So I get the value of L. If that value of L is positive, greater than 0, and finite, meaning it also converges. The whole expression converges. That's the deal about that's the idea about what's this? About the limit comparison test. Okay. Do we have any queries up to that point? Okay, I hope not, since I'm unable to get any feedback. Okay, so question 7 it says question 7 says determine the convergence or the divergence of the following series using the ratio or the root test. So I haven't explained much on the, I've done many examples on the ratio test. So it simply means I know this one and this one is a ratio test, obviously. Then this one and that one is the root test. Okay, so I'm going to do one example under the root test. Since I've done many on the ratio test, you can try to do this one and this one, then see what you're going to end up with. Okay, so example question 7a, it's I'm going to apply the root test. So you have n is equals to 1, then to infinity. Then here you have 2 to the n multiplied by 3 to the n divided by n to the n. Okay, so what happens here is that for the root test, this can be expressed in the form, you say the limit as n approaches infinity of nth root. This will be n, then you say absolute value of a sub n, like that, meaning that would be the limit as n approaches infinity. So I'll say nth root of, this is actually, you can simplify this. This can be written as 3, or rather, this can be written as 2 multiplied by 3 divided by n to the power n, like that. Okay, so remember to say the root can be written in another way. Okay, so that would be like open bracket. I'll say open bracket 2 times 3 divided by n to the power n raised to the power 1 over n, of which that this n, like it can cancel out, so just remain with what? You just remain the limit as n approaches 6 over n. This goes to 0. Okay, this goes to 0. So remember to say we are looking for the value of L. If the value of L is greater than 1, it what happens? It diverges. If your value of L is less than 1, it converges. If your value of L is equals to 1, meaning you can't make a conclusion from that, and you try to apply another method. Okay, so that's about the root test. The other ones, B and C, you can apply the ratio test. I've used it severally here. Then D, you can try it out. That's also the root test that is going to work out. Okay, so question 8, it said first Find the first four non-zero terms of both the Maclaurin series and the Taylor series at x is equals to c, generated by the following functions. So these are very simple. Okay, these are very simple. One thing that you have to remember is that if you know the Taylor series expression, then you are good to go. Okay, so the idea is how can I write it? The expression is going to be something like this. The Taylor series can be written in this way. You have your f. Let me see. You can say f um, f to the n of c. Okay. Then here I'm going to say x minus c to the power n divided by n factorial. This is an expression for a Taylor series. Okay. Then for a Maclaurin series, a Maclaurin series is just a Taylor series centered at 0. So meaning for this one, c is equals to some expression, some value k. But for a Maclaurin series, you're going to say f to the power n of c here, where c is actually a 0. So I can just write this as f of 0. Then here that will be x to the power n divided by n factorial. Okay. So when you pick one of these examples, let's say which one can I pick? Let me pick the last one, which is h of x is equals to the square root of 1 plus x, which I can write as 1 plus x to the power 1 over 2. Okay, so what this means is that, you know, when it comes to the Taylor series and the Maclaurin series, if you know how to differentiate, then you are good to go. Okay, so here I can, since I'm looking for the first four non-zero terms, so I can just go ahead and differentiate. So it's like more like differentiating 4 times kind of thing. So if you know how to differentiate, then you're safe, as I said. So here your h prime of x will be equals to, just using the chain rule, this will, the power will drop, that will be 1 over 2. You have 1 plus x to the power minus 1 over 2. Then h prime prime of x will be equals to, this will drop, you're going to have minus 1 over 4, 1 plus x to the power minus, you say minus 1, that will be minus 3 over 2. Then h prime 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 of x will be equals to positive 3 over positive 3 over 8, 1 plus x to the power minus 5 over 2. Then h to the fourth of x will be equals to, that drops, you're going to have minus 15 divided by 16, 1 plus x to the power minus 7 over 2. So what happens here is that for on all these derivatives that you have, in fact including this original function that we have, for a Taylor series, you have to substitute with for example, for a Taylor series, you have to substitute. Here you are told to say for a Taylor, c is equals to 3. Okay, and it's actually been stated in the equation at x is equals to c. So for a Taylor series, while you have x here, you substitute with what? You substitute with a 3. Then you find what the value is. So it's like for this one, let me see what it's going to become when you say Taylor. Okay, so if you say h of c, in this case our c is what? We are told that our c is equals to 3. If you plug in 3 here, this will be equals to, if you plug in 3 here, it will be 3 plus 4, which is 4, sorry, 3 plus 1, which is 4, square root of 4 is a 2. So h prime of 3 will be equals to, it will be equals to 1 over 4. Then h prime of 3 will be equals to minus, it will be minus 1 over, you get to 8, 8 times 4 is 32. Then h prime of 3, you get 3 over, I'll need a calculator for that one. 8 times Just a minute. I get 32 times 8. I get 256. Then the other one, we have to the fourth here of 3, meaning it would be minus 15 over what happens there. We get 4 to the power 7 for 2, sorry, rather 2 to the power 7, 2 to the power 7 multiplied by 16. I get 2048. Okay, so this is what we have, but remember to say the final expression is going to be written in the form you're going to be saying first of all what we have here, this since I'm using h, okay, this is going to be written in this way. You're going to start with h of c, okay, of which we have substituted, which is a 2, okay, then you say plus h prime of c multiplied by x, it's like x to the power 1 divided by 1 factorial plus h prime prime of c, sorry, just a minute, forgotten something here. So this would be h prime of c, then here it would be x minus c, like that. Then you say plus h prime prime of c, here you say x minus c to the power 2 divided by 2 factorial. You saw, meaning you keep on going, h prime 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 of c, then you say x minus c to the power 3 divided by 3 factorial. So here just plug in 3. You know what 3 factorial is? For this part you already have it, it's this one here, that's what it means. But this is for a Taylor series. For a Maclaurin series, not to say your c is equals to 0. That is the idea. Okay. Uh, any question? Do you have any question? People have left the meeting. Should I continue or just record this? All right, let me continue. Okay, so that was that about question 8. Just differentiate, know the difference between the Taylor series and the Maclaurin series. The Taylor series is just like the generalized point of view. The Maclaurin series is a Taylor series centered at c is equals to 0, meaning centered at 0. Okay, then question 9, actually we're almost done, let me just finish it up. Question 9 is saying find the radius and interval of convergence of the following series, which is something that usually, I'm not saying it's going to come, but it's something that doesn't miss sometimes when it comes to these questions. For the radius and interval of convergence, what you need to remember is this. I'm not going to waste your time talking about the whole thing. I'll just go straight to the point of what you need to do. It's actually written as x minus c. It's the absolute value of x minus c less than r. Okay, this r is your radius of convergence, and this is how you determine your interval of convergence. So one thing you need to remember is that for you to come up with your interval of convergence, you need to know, or you need to remember the ratio test and sometimes the root test, maybe. Okay, so the idea is this. There are times when you can there are times when after evaluating what you have, okay, if you say if you have the limit as n approaches infinity, after applying the ratio test, if you have something, let's say you have a sub n plus 1 divided by a sub n. Remember, this is from the ratio test. If you get, for example, if you get say you get a 0, okay, say you get a 0, then there's a time again when you say the limit as n approaches infinity of a sub n plus 1 divided by a sub n. If you get infinity, this can be simplified in a certain way, okay, meaning you only get to break it down sometimes if you get some other values other than 0 and infinity. Okay, just give me a minute. Yeah, okay, sorry about that. So if you evaluate the using the ratio test, then you end up with if you end up with a 0, for simplicity purposes, your radius of convergence is just going to be 0, meaning your interval of convergence, which I can write as I, will be equals to, it will start from minus infinity to positive infinity, meaning it's all real numbers, okay? But if you evaluate then end up with infinity, what this means for you is that your radius of convergence is equals to 0, then the interval of convergence is not really an interval, it's just going to be a single point, which is 0 itself, like that, okay? So this is one thing that you have to, this actually simplifies your work sometimes. If you end up with 0, always remember your R is infinity, your interval is all real numbers. If you end up with infinity like that, your R is a 0, meaning you don't have an interval, you just have a single point, like that. Okay, so let me try to use one of what we are given there as an example. So let me see which one can work best here. So let me look at this one here. That is question 9a. You are starting from n is equals to 1 to positive infinity, then you have your x plus 4 to the power n divided by n multiplied by 3 to the power n. So here you're applying the ratio test, so your a sub n plus 1 will be equals to your x plus 4. You're supposed to say n plus 1 here, but I won't write it like that. I've already explained why. That will be x plus 4 like that, divided by, here I'll say n plus 1 multiplied by 3 to the power n multiplied by 3, instead of saying 3 to the power n plus 1. So I'm going to say the limit as n approaches infinity. So this would be a sub n, which is x plus 4 to the power n multiplied by x plus 4 divided by n plus 1 multiplied by 3 to the power n by 3. This you're going to multiply by the reciprocal of a sub n, which is n by 3 to the power n divided by x plus 4 to the power n. Then this and that goes, that and that cancels out, okay? So what you remain with is I can write it this way. For this part, it's just something that I had, like if it's more like you had absolute value of, we said the x minus c, which I can bring on the outside, that would be like x plus 4 like that. Then you say the limit as n approaches infinity. Then inside here you're going to remain with, you have this n here, which is n divided by, then here you can write your 3 n minus 3, like when you expand this by this 3 that you have here, okay? So how you evaluate this is basically up to you. So what I can do is that I can simplify this, okay? This I believe is actually equals to 1 over 3. Why am I saying so? Because if I multiply the inside part, like everything, by 1 over n, that would be like 1 over n by n on the numerator, you just get 1 divided by 1 over n by 3n, that will just be 3, minus 3 by 1 over n, that will be 3 over n. If you plug in infinity there, you get a 0, so that's just going to be 1 over 3. So it simply means what you end up with here is 1 over 3. Okay, that's 1 over 3. So what this tells you is that your radius of convergence is equals to what? Is equals to 1 over 3. So if I got a 0, remember I could have said r is equals to infinity. So what now this is telling me is that the interpretation here, the interpretation is that your x plus 4 is less than 1/3, like that. So I've gotten my radius of convergence. Then from there I can determine the interval of convergence. So the interval of convergence is just going to be, remember to say these are absolute value symbols. So if you get rid of them, this is just going to be, this will move on the other side and become negative, like it has a negative part of it. So that would be like -1/3 less than x plus 4 less than 1/3, a positive part. So you can move 4 on this side as well as on the other side. So this is going to be, when it moves on this side, it will be minus, you have like -1/3 minus 4, that's going to be, I think, 13/3. You have -13/3 less than x less than, on this side you're going to have -11/3. So this is here is partially the interval of convergence. So how you confirm whether it's really it or not, what I mean is these symbols here. This I could have chosen to write it as less than or equal to, even this one less than or equal to, but why haven't I done that? I'm not really sure whether this one is part of the endpoints or it's just, I mean, like, I'm not really sure. So what I'm going to do is that you're just going to pick this value, plug it here where you have x. So for example here, you're going to come and say, instead of x there, you're going to put minus 3/4, sorry, 13/3, 13/3 plus 4, then to the power n divided by n3 to the n. This will be equals to, if you make this a single fraction, 3 times 4 is a 12, 12 plus minus 13 is actually -1/3 to the power n divided by uh, n 3 to the n. So this can be simplified this way. You can have like -1 to the power 3 divided by 3 to the power, sorry, not the power 3 but the power n. So this will be to the power n divided by 3 to the power n divided by n 3 to the power n, like that, of which these three, that one and that one can cancel out, so meaning you're going to remain with the limit as n approaches infinity of -1 to the power n divided by n. So how you evaluate this is basically up to you, and I believe what you're going to have is something like, if you are to use the ratio test to evaluate this to see if it converges or not, you're going to have the limit as n approaches infinity of, that would be your -1 to the n multiplied by -1 divided by n plus 1 multiplied by n divided by -1 to the n. This and that cancels out, so this will also be positive because of those symbols, absolute value symbols. Sorry, this is 11 here, so this will be the limit as n approaches infinity of n divided by n plus 1, of which this can be simplified, and this is just going to end up to be 1. Okay, this will be 1, so it converges. So it simply means this one here is actually supposed to be less than or equal to. So you do the same for this one, try it, plug it there and see what you're going to get. If it diverges, meaning you leave it as that. If it converges, meaning it's less than or equal to, or if you're using greater than, meaning greater than or equal to. That's the idea about interval of convergence as well as the radius of convergence. Sometimes the questions are open, determine the interval of convergence, they don't say determine the radius, but always remember you can't find the interval of convergence without having the radius. Okay, then question 10, I won't do it. Reason being is that I've already done this on question 8. It's still the same. Remember to say the question is saying find the Maclaurin series of the following functions. So how you find the Maclaurin series, maybe just a reminder here is, a Maclaurin series is the one that is in the form just a minute. It's the one that is in the form f f to the n of c multiplied by x to the n divided by n factorial. Okay, so meaning this is just going to be like f of c plus f prime of c x here plus f prime prime of c by x squared divided by n factor divided by 2 factorial plus f prime 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 of c by x to the power 3 divided by 3 factorial. So what you do is that on this question, just differentiate as much as you can. It's up to you, but they advise to differentiate usually maybe up to like the fourth derivative, then you where there's x substitute with a 0 so that you determine what your f of c is. Remember to say, I've just used c here, but remember to say for Maclaurin series c is equals to 0. Okay, that's the idea. Then question 11, you say use the Maclaurin series for ln of 1 minus x to approximate ln of 3 over 2 so that the absolute value error is less than 10 to the minus 4. Okay, so this question is very, very interesting and simple at the same time. So you're given ln of 1 minus x. Okay, you want to use it to approximate ln of 3 over 2. So if you go to your calculator just now, if you go to your calculator, you say ln of 3 over 2, which is 1.5, is 0. My calculator is giving me 0.40546510810816, something like that. So whatever that I'm approximating, you need to remember to say for we are using Maclaurin series, and as many terms as you use, that's what is going to the closer you are to the actual value, because remember to say this is just an approximation. Okay, so don't worry much about yeah. So what it is here is that this one here, I'm going to manipulate it. Okay, so what I have is 3 divided by 2, which is actually 1.5. What is the other way I can write 1.5? I can write this as 1 plus 0.5, which is same as 1 plus 1 over 2, like that. Okay, so meaning since I have a plus here, okay, and I had a minus here, what it means is that my x is equals to minus 1 over 2, like that. Okay, so it simply means I'm going to use the series x plus what? X plus 1 over 2, sorry, not x, but 1 plus 1 over 2, which is this one here. I'm just manipulating so that I have a 1 here, then here whatever that I have is the x, and in this case my x is negative 1 over 2, which I've indicated. So if you find the Maclaurin series of this here, the Maclaurin series, I'm going to leave that work for you. If you find the Maclaurin series of this one here, like the same way, differentiate about maybe 4 or 5 times, what you're going to end up with something like minus is it a minus? That would be something like just a minute. No, it will actually be positive. Let me analyze this. It will actually be positive. It's going to be positive. It might be positive or negative. I might be wrong. So this is going to be absolute value of, that would be the Maclaurin series of that one there. That would be from n is equals to 1. Then here you're going to have minus 1, n plus 1. Then this will be what will this be? Here you're going to have x to the power n divided by n, like that. Okay, so what happens here is that you can just start picking out values. For example, let's say n is equals to 1. If you plug in where n is equals to 1. Remember to say we said our x is equals to minus 1 over 2, but we are going to use the positive part because of the positive one that I have here. Okay, so it simply means here this is going to be like minus 1 here. If you plug in 1, okay, if you plug in 1, this is going to be 2. Okay, then you have 1 over 2 to the power 1 divide by 1. What does this become? This becomes positive 1. That's just remain the same, so you have 1 over 2 like that. Then if you try n is equals to 2, meaning this will be negative 1, then that's just going to be 3. You have 1 over 2 to the power 2 divide by 2 here. This is just going to be negative. This will be 1 over 4, meaning this will be 1 over 8 like that. Then try out n is equals to 3, for example. You're going to have negative 1 to the power 4, then you have 1 over 2 to the power 4 divided by not 4 sorry, not 4 but 3 3 here, then divide by 3. This is going to be positive, so you end up with something positive, so it will be 1 over 8 times 3, that will be 1 over 24. It's a positive. Then try out n is equals to 4, for example. It will be minus 1 to the power 5, 1 over 2 to the power 4 here, divide by 4, which is going to be equals to negative what would this be? 2 to the power 4 is 16. 16 times 4 is 64, so that would be 1 over 64. So now these values, let me try out, for example, to say 1 over 2 plus, or in this case it's a minus, it's minus 1 over 8. Then we have plus 1 over 24 minus 1 over 64. Let me see what I get on my calculator here. So if I say 1 over 2 minus 1 over 8 plus 1 over 24 minus 1 minus 1 over 64. Okay, so the value that I'm finding here, I don't know if you're finding the same, you're finding 0.40104116, something like that. So observe this is closer to the actual value that we have. We are approximating. So that error that they give you, which is 10 to the power negative 4, which is actually 0.001, I think. 1, 2, 3, 4, yeah, 0.001. This is an error. Okay, so it simply means here I was supposed to have like something like a 0.403, something like that. So you observe to say that as many values as I add, the closer I'll be to the actual answer. Okay, so that was the idea. Just determine what the Maclaurin series is. You know how to determine the Maclaurin series, I've taught you that. Then go ahead and try out substituting values like n is equals to 1, n is equals to 2, n is equals to 3, up to as much as you have depending on time, but maybe not less than 5 or not less than 4. Okay, then the final question, which is question 12. I used to get a lot of questions on this one, and this is one of the easiest questions that I've ever done. Question 12 is very, very simple. So it says, given that arctan is equals to x minus x to the power 3 over 3 plus x to the power 3 over 3 minus x to the power 5 over 5 plus, you are given it's like what you have here. This one here is the Maclaurin series of arctan x. Okay, then you want to use that to evaluate these integrals. So how you use that to evaluate these integrals is very, very simple. You're going to evaluate them in terms of series. So remember, arctan x has been given we have been given this series. Where is it? Okay, you have been given minus 1 to the power n minus 1. Then you have 2. Sorry, you have x to the power 2n minus 1 divide by or let me just this part divide by 2n minus 1. So you want to evaluate one of the integrals. Let me use the first one as an example, which is from 0 to 1. Then here you have arctan x squared divide by x by dx. So the idea here is, if you observe here, I have x. Okay, here I have x, then I've been given that. Okay, so what happens is that on this same series, for me to write arctan x squared, for simplicity purposes, I'm going to write this as minus 1 to the power n minus 2. While you have x here, substitute with x to the power 2, you close the bracket, then you have 2 to the power, so you have 2n minus 1 divide by 2n minus 1 here. Okay, so this ends up giving you minus 1 to the power n minus 2. Then here you're going to have x to the power 4n minus 2. Then you say divide by 2n minus 1, like that. Okay, but remember, I'm still going to divide by some other x, like it's just going to like more like divide by x or multiply by 1 over x. Where is that x coming from? That x is coming from this part. I have this x here, so it's like I'm supposed to put it here. But for simplicity, once again, it's like you have x to the power 4 minus x to the power 4n minus 2 divide by x to the power 1 here, like that. So what do? You can actually subtract the powers. Okay, you can just go ahead and subtract the powers because they are dividing each other. If you're multiplying each other, you add the powers. So I mean, this would be like x to the power 4n minus, when you subtract the power, this would be 3. So you can just write this as what? As a 3, like that. So that is the expression for what? I can actually just include this here and say divide by I can say divide by x there, like that. Divide by x, that's what we end up with. Okay, so now to evaluate the integral, just get the part that has x. So remember, you're evaluating from 0 to 1, so just get this portion here. Okay, so what this means is that from a generalized point of view, you can write this as to say the limit as n approaches infinity. So this is going to be equals to your evaluation is going to be based on the fact that you have minus 1, okay, minus 1 to the power n minus 2 divide by 2n minus 1. Then the part that has x here, what you do is you're going to say it will be multiplied by the integral from 0 to 1, okay, of x to the power 4n minus 3 dx. Okay, when you integrate this part, it's just a matter of adding the power. You do the same on denominator, and so to be like x to the power 4n minus 3 plus 1 divided by 4n minus 3 plus 1, which is just going to be x to the power 4n minus 2 divided by 4n minus 2. Okay, so I can just erase this part. To say multiplied by am I done? No, sorry, I'm not done. So here, I remember you're still evaluating, so that would be x to the power 4n minus 2 divided by 4n minus 2, evaluating from 0 to 1. So if you plug in 0, you get a 0. So just plug in the upper limit. So if you plug in 1 here where there is x, regardless of what the power is, this will still be 1. So you just end up with 1 over 4n minus 2. So this will be 1 over 4n minus 2, like that. Okay, so from here now, you can go ahead and use whatever method that you want to use, to either the ratio test, the root test, or anything. You're going to get your value of L, and that will be your answer for the integral that you have been given. And that's basically what tutorial sheet 4 is all about.